In this video, we're given the implicitly defined function y times y squared minus 1 times y minus 2 equals x times the quantity x minus 1 times the quantity x minus 2. Now this is not a function that's going to be able to be solved for y. Now what we are also given is dy dx is the following rational function involving both x and y. And we're going to do a few problems on this. In this video we're going to focus on identifying where it has horizontal tangents. Let's take a look first off at the graph. And so if we're looking for places where the tangent line is 0, we can see several of them in this graph. Let's just see how many we would expect to find. So we see one here, 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 got one there, 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 and one more. So we got a whole bunch of places where this thing has vertical tangents. 1, 2, 3, 4, 5, 6, 7, 8. Now something interesting about those horizontal tangents is they lie on the same x line. So we're probably only going to come up with 2 x values where this thing has a horizontal tangent. So let's see if we can confirm this based on what we see in the graph. So first off, let's find horizontal tangents. Now horizontal tangents from this thing is going to come from where the numerator is equal to 0. So we're going to go ahead and take our numerator, which is x minus 1 times x minus 2 plus x times x minus 2 plus x times x minus 1, and we're going to set that equal to 0. This is going to simplify down to just give us a quadratic that is 3x squared minus 6x plus 2 equal to 0. Solving that with the quadratic formula would give us the 2 zeros that we saw in there, which is x equals 3 plus or minus rad 3 over 3. In this video we're not going to focus on using the quadratic formula. That's something you've done in the past. These are, as decimals, approximately 0.423 and 1.577. Let's confirm that with our graph. So based on our graph, my lines weren't really perfectly straight, so it looks like I was a little off. So right there's the first x value, a little less than a half. That corresponds to this one. And this one here looks like it's a little bit more than 1.5. So that'll correspond to our other one. So those look like they make sense. Now let's talk about how we would figure out what the y values were so we can find the actual points. What we're going to need to do is plug these x values into our x values here. And the more accurate we are on these, the better. So what we might do is we might actually, let's just do one of them, and then it's going to be a similar method for the other. So first off, we'd probably go ahead and multiply the y's out. So that's going to be y times y cubed minus 2y squared minus y plus 2, which is going to give us y to the 4th minus 2y cubed minus y squared plus 2y. And now what we're going to do is we're going to set that equal to this side with one of our x values plugged in. So let's see, 3 plus rad 3, I'm going to do the plus first. 3 plus rad 3 over 3 minus 1, that's putting it into this term. And 3 plus rad 3 over 3 minus 2. Now what we have is a 4th degree polynomial equal to some number. This thing, if you calculate it, is going to be about 0.3849. And so then we'll use this equation here. We'll plug this into a graphing calculator or some kind of computer algebra system such as Maple or GeoGebra to get the corresponding y values, and there's going to be 4 of them. So the y values that you'll get from this equation are about, let's do them to about 3 decimals like we've been doing. So the y's are going to be negative 1.058, 0.229, 0.771 actually at 3 decimal points, 2.058. So we're going to have 4 points here, and those 4 points are going to be 0.423, comma, negative 1.058, 0.423, they're all going to have the same x value, comma, 0.229, 0.423, comma, because they all came from the same x value. We put in the 0.423 here for our x's. 0.423, 0.771, and finally 0.423, 2.058. Now we had confirmed those the x value. Let's confirm those y's and make sure that they make sense based on what we see in our graph. And we're going to try and get the whole thing on here. So we'll just do a couple of them. For instance, 0.423 and 0.229, that's going to be our horizontal tangent right here. And that looks like pretty accurate. The last one, we'll just do a couple. 0.423 and 2.058. It's going to be our point right here where there's the horizontal tangent, and again, looks pretty accurate. So that's how we would find all the ones that lie on that vertical line. To do the other, we would do pretty much the same thing, except we're going to use the other 0 plugged in here for x to go ahead and get our points. So that's how we could find the horizontal tangents for this